Okay, welcome back. So we're going to do some examples now with the equations of motion. We are on page 13 and we're doing example 3. So a roller skater decreases her velocity uniformly, so that means constant acceleration. That's what uniformly means. From 8 meters per second northwards to 4 meters per second northwards in 3 seconds. What is her acceleration? So the first thing we need to do is define which way is positive, and I'm just going to say northwards is positive, and then we write down SUVAT, S-U-V-A-T, and we need to know, we have to firstly know what do we actually know. So we know that initial velocity is 8 meters per second, and it's northwards, so it's positive, so 8.0 meters per second. Then our final velocity is 4.0 meters per second northwards, because that's what it's decreased to. And again, that's positive. Acceleration, that's what we're looking for. And time, we have the time of 3.0 seconds. So once we have found out all that we know, we don't know what the displacement is either, but we're not necessarily looking for that. Once we know what we know, we look at our equations of motion on our formula sheet, and we have to decide which one of these 4 that we're going to use. So in order to decide, we're looking for A, and we've got U, V, and T. So the formula that we're going to use is this one here, the second one. So V equals U plus AT. Okay, so we'll just write that down. V equals U plus AT. But we're looking for A, so we want it in terms of A. So you can do this 2 ways. You can either rearrange the equation without putting the numbers in, or you can substitute the numbers in and then rearrange the equation. It doesn't matter either way. First off, I'm just going to rearrange it without putting the numbers in. So the first thing we need to do is subtract the U from both sides. So that's V minus U is equal to AT. And then we've got A times T, so we need to divide both sides by T. So we get V minus U divided by T equals A. And now we've got this way, we can just go A is equal to V minus U divided by T, like that. Okay, so now we just need to substitute the numbers in. So A is equal to our V minus U, so it's actually 4 minus 8 divided by 3, which is equal to A is equal to minus 4 divided by 3, which is equal to, that's not a very nice 3, is it? I'm just going to go back. Let me go back and let's redo that 3. Okay, so then A is equal to minus 1.33 meters per second, and the direction is northwards. Okay, so it's a negative acceleration, and I always do this. I always put a 1 there. That should be meters per second squared. I always do that, so just watch out for that. Okay, so A is equal to negative 1.33 meters per second squared northwards, which is equivalent to an acceleration in the opposite direction of northwards, which is southwards. So our final answer will be A is equal to 1.33 meters per second squared southwards. Oops, and there's got an R in there, southwards. And we usually want to have our final answer as a positive number, but those 2 are equivalent. Okay, so you could leave it this way. I'd still mark that as, I'd still give that 4 marks if you left it this way, because you've got your magnitude and direction, but often we like it in positive numbers.